So we're looking at practice test number 2, problem number 2, and the problem states the following data is the cost of a dinner in various restaurants. And we have here 8 data points given to us. We're going to first calculate the mean, median, and mode. And in the calculation of the mean, which we often call the average, we're going to sum up all of our data points, add them together. That gives us 336. We divide by the number of data points n, which is 8, and we get 42 for the mean. This formula right here is the formula for the mean. X bar is what we call the mean. This is your summation symbol from 1 to n, and n is always the number of samples, or the sample size, and it's 8 in this case, and x sub I is all of your data points. We're going to add them all together and divide by n. The median is the middle point when the data is arranged from the smallest to the largest. So we arrange our data in that order. When we have an even number of data points, we're going to have 2 in the middle. So we average them, we add them together and divide by 2. And again, we get a median here, which is the same as the mean of 42. The last thing we calculate here is the mode, and the mode is the most frequently occurring data point, and we find that we have 2 39s right here, and then we have 2 43s right here, and so both 39 and 43 occur twice. They are both modes, and it is possible to have more than one mode. If we go over to the next part of the problem on the next page, now we're calculating the measures of the variability of the data. And the first measure of variability is the range, which is the high point minus the low point. And we had a high of 49, a low of 35. The difference between them is 14. That's our range. A better measure of the variability is the variance, especially the standard deviation, and that's what we calculate next in this table. What I do in the first column is I arrange the data from smallest to largest, and then in this column I find the difference between each data point and the mean, which is 42. So 35 minus the 42 gives me minus 7. 39 minus 42 gives me minus 3, and so on. And so I find the differences between each data point and the mean in this column. Then in this column I square the difference, and so I have minus 7 squared gives me 49, minus 3 squared gives me 9, and so on down through the column. And then at the bottom of the column I have an extra row here where I sum all of these squared differences right here. I sum up the column and I get 144. I'm going to use that number in the calculation of the variance, because here's the formula for the variance, and you notice that the numerator is the sum of all of the squared differences, the sum of all this column, which we found to be 144. And then the denominator is n, which is 8, minus 1, which is 7. N is the number of data points. 8 minus 1 is 7. We do the division, and we have a variance of 20.5714. The standard deviation is the square root of the variance. So this number right here, I take the square root of it. You notice that this formula here is the same as for the variance. I'm taking the square root of the variance, and I get my standard deviation, which is 4.5356. The next thing we calculate is the z-score, which is the z-score is the number of standard deviations that each data point is away from the mean. The formula for that is right here. I take first the difference between each data point and the mean, and then I divide it by the standard deviation. Now the difference between each data point and the mean I've already calculated in this column. So what I'm really doing is I'm taking the difference here and I'm dividing it by the standard deviation that I found here, and that's going to give me the z-score right here. So if you look at all of these calculations down here, what I'm doing is I'm taking each difference, dividing it by the standard deviation to get the z-score, and so on. So minus 7 divided by 4.5356 gives me this z-score here. Minus 3 divided by 4.5356 gives me this z-score right here, and so on down through the column. And then the next thing that we want to calculate is what is called the coefficient of variance. And that is, the formula is given to us here. It is the standard deviation relative to the mean. And what you're going to do to calculate it is take your standard deviation and divide it by the mean, multiply by 100, and you're going to get the coefficient of variance right here. The next question is based on the z-scores above. Are there any outliers? And an outlier is defined as a data point that has a z-score of greater than 3, either less than minus 3 or greater than positive 3. And we see no z-scores here that are less than minus 3 or greater than positive 3, and so the answer is that we have no outliers in our data. The last part of this question is to describe the data, whether it's symmetrical, right skewed, or left skewed. And the way you do that is you first look at your median, which we found to be 42. Then you look at your mean, and if your mean is the same as your median, the data is symmetric. And that is the case here, that the median and the mean are the same, so the data is symmetric. If the mean were greater to the right of the median, it would be right skewed. If the mean were less than the median, to the right of the median, or to the left of the median rather, it would be left skewed. So that is problem number 2 on practice test number 2.